Plate tectonics is a scientific theory that takes to explain major geological processes on Earth. Creation and development of continents and related structural processes in and below the Earth's lithosphere. Yes, you already know this. But have you ever asked yourself, why do all of illustrations and representations of this scientific theory look like artist conceptions? Or to be more straightforward, why do they all look like kids' drawings? Nowadays even a single person on a very limited budget can produce computer-generated models of highly complex mechanisms. There are 20,000 geologists in Canada alone, countless around the world. Numerous universities with big enough budgets, so why there isn't one for the plate tectonics? Well, it's because it cannot be done. It cannot be done, because no engineer can tell what exactly is he supposed to model. You might be very surprised, but the actual description of the plate tectonics mechanism does not in fact exist. There is no such thing as official, so to speak, description of the plate tectonics mechanism. In itself, the basic concept behind the plate tectonics is quite simple. According to the claims, below the Earth's crust there is much thicker layer of mostly solid rock. Geologists call it mantle. This layer is very slowly moving. Due to the heat radiating from the Earth's core. It essentially acts as a conveyor that carries the continents on top of itself. Now, this concept is not new, it was proposed long time ago and you would never guess by whom. Even early attempts to model and visualize this concept were made. Turtle stands for slow. An elephant stands for power. A slow-moving power that is carrying Earth's continent on top of itself. But beyond this basis most of the claims made in the theory are either excessively generalized or focused on a very small segment disregarding this segment's interaction with the rest of the mechanism. They are either mutually exclusive or simply anti-intuitive. For this reason geologists don't make an effort to present this mechanism in its entirety and prefer to present it in separate segments and in the form of artistic conception. For the reason that artistic conception doesn't have to conform to the constraints of the physical world. And any particular segment's correlation with the rest of the assembly can be left to the viewer's imagination. In turn, viewer's imagination doesn't have to conform to physical constraints either. Viewer can see continent floating in the ocean just like a boat. And crushing into the shore. And everything seems logical. So this is easy and convenient way for the geologists to present their theory. But for the engineer who is to model this mechanism, or for anyone else for that matter, it's very hard. For them there is no ocean, it is irrelevant. For them there is only hard solid rock. Many kilometers thick. And below this, there's another layer of mostly solid rock 60 times as thick. Now, you have to make this piece crush into this one. And you have to do it from the inside. A lot could be said about the problems with plate tectonics, they are many. And one would run into them right from the very beginning. For example, according to the theory, in the beginning there was a single continental crust named Pangaea, which later broke apart and separated into the continents as we know today. Now, there is a very important part left out in all of the representations of Pangaea. Mid-ocean ridges. As we know, mid-ocean ridges are absolutely essential for the plate tectonics. And there is a reason why they are left out. If they were represented, it would become obvious that at the beginning of the process of separation these ridges would have to be concentrated on Pangaea itself. And in order to get to the place where they are today, they would have to travel and expand, so to speak. And the only way they can do this is to eat through the lithosphere, or in other words, to melt and recycle lithosphere while expanding their boundaries at the same time. And this is contradictory to the claims of convergent and divergent boundaries, push and pull slabs and other claims. And that's just the beginning. In short, computer-generated model of the plate tectonics doesn't exist because the theory is not even unified. It is too contradictory and complicated even to the geologists and proponents themselves, and to the extent where they are unable to explain to the engineer who is to model this mechanism, what on earth is he supposed to do. But let's get back to the crawling continent. How is the crawling continent different? What does it propose? It proposes that continental crust and oceanic crust are two separate layers of lithosphere. And plate tectonics mechanism applies to the oceanic crust only. Continental crust on the other hand, or the Earth's continents, is slowly moving on top of the ocean floor. And it does so due to the inertia. Inertia is the effect you feel when the bus you are standing in increases its speed of travel. And you feel as if the floor is slipping from under your feet. The more mass the object has, the more inertia it has. And we would agree that continents do have plenty of mass. In our case, inertia comes not as a result of increasing bus speed, but as a result of increasing speed of Earth's rotation. Why would Earth's rotation be increasing, and how did continental and oceanic crusts become separate layers in the first place? Let's find out as we uncover the driving force behind. For better understanding, let's look at few related facts about our solar system first. Sun is at the center of the solar system. And all of the planets lay in the plane of Sun's equator. Their orbits forming a virtual disk around the Sun. They are divided into inner and outer planets. And between them lays the asteroid belt. There are 4 of the inner planets and Earth is one of them. They are all very similar to each other. Both in size and composition, as opposed to the outer ones. Another interesting fact about the inner planets is that their speed of rotation increases in relation to their distance from the Sun. Further the planet is from the Sun, the faster it spins around its own axis. Mercury is closest to the Sun and it rotates very, very slowly. Venus is further away and it rotates much faster than Mercury. And same goes for the Earth and Mars. Now, let's add the driving engine. Driving engine is a tiny relative of a much more powerful force, effects of which we can witness if we look at the galaxies. Not all galaxies have spiral arms, but many of them do. Those spiral arms we see are made up of stars, and the invisible force that is making those stars line up in such patterns is largely unknown at the present. It is important to note that center of the galaxies is made up of gas. And they do rotate. And you guessed it, Sun rotates as well and is made up of gas too. Even some planets, like Saturn for example, are made up of gas. Even though the force behind the spiral arms is elusive, its effects can be observed. If this force was present in our solar system, what effect would it have on it? Would it influence our ocean tides in any way? Could it be powerful enough to affect the rotation of the planets and their orbits? To summarize, the crawling continent concept proposes that the Earth, just like other inner planets, originated from a cloud of ionized gas very close to the Sun. And the plasma cloud in turn, originated from the Sun itself. This plasma cloud is constantly lashed by the spiral arms of the Sun, and it eventually begins to swirl. At the center of the swirl, fusion of the core happens and the rest of the planet forms around it. As the spiral arms are lashing against the planet, its orbit path is ever so slightly moved away from the Sun. Until it gets out of the reach. And there it stays, in its final orbit. And this process repeats. With more planets reaching the final orbit, they are colliding and breaking up into pieces. Forming an asteroid belt as we know today. In the beginning, planet is very close to the Sun and temperatures are extreme. Planet is boiling hot. Its rotation slowly increases as well, and inevitably, during a certain period its rotation time equals its revolution time. In other words, it spins once around its axis as it turns once around the Sun. This is exactly how Moon revolves around the Earth. Which means that during this time period it has one side always facing the Sun and the other one facing the cold space. As a consequence, difference in temperatures on two sides of the planet, during that period of time are huge. And eventually on the colder side facing the cold space, thin crust begins to form. This first crust is what we know today as Pangaea continent. As Pangaea gains mass it gains inertia as well. And it begins to slowly float over the surface. Or to be more precise, the surface begins to slip under. As the planet continues to move away from the Sun, its rotation speed continues to increase. One side is no longer always facing the Sun, and entire surface of the planet eventually cools off. But Pangaea continent continues to crawl over the surface of the Earth, breaking apart as it does so. New subcontinents are colliding amongst each other as they all move opposite to the Earth's rotation. And the mountain chains are rising along the lines of their collision. This process continues for billions of years and into the present. But few 100 million years ago, first crack appears in the oceanic crust as well, along the lines of what we know today as Mid-Atlantic Ridge. And new process begins to take the stage. Magma from inside of the planet rushed through the crack and begun to pile up on top of the Atlantic Ridge, rising up high until it created a mighty chain of volcanic mountains, which are known today as Cordilleras and Andes. Slowly moving continents eventually crawled up to the Atlantic Ridge, and they collided. In slow motion but with tremendous force. And the mountain chain was dislodged. But magma kept leaking through the crack below the continents, building up heat and pressure for millions of years, until it exploded in terrible event that destroyed most of the life on Earth. Event which we know today as Great Extinction. The crack which opened up along the Atlantic Ridge, it spread all over the ocean floor. New structural process was born. Plate tectonics came into force.